So now we can look at how to express concentrations of solutions using different units. And you may have seen some of these before. Mass percent, we looked at mass percent in Chem 1 when we talked about percent composition. And mass percent is just the mass of your of some part of your solution divided by the total mass of your solution times 100. So the percent is why we have the times 100. So the way you can interpret something like that is here, if we had 36% by mass hydrochloric acid, that means I really have 36 grams of HCl. Assume this is an aqueous solution. I have 36 grams of HCl in 100 grams of solution. And so if you remember, what are the two parts of your solution? You have two parts in your solution. You have a solute and a solvent. So HCl here, this is going to be my solute, right? So if I have 36 grams of solute, and I have 100 grams of solution, right? That's my total mass of solution. So if I did 36 grams of solute over 100 grams of solution times 100 is going to give me 36. So that's where it's going to give me 36%. So if I assume I have 100 grams of solution, and this 36% is telling me I have 36 grams of HCl then. This makes it really easy because then I can figure out how many grams of solvent I have. So if my solvent is water, then I know that I have 100. 100 has to equal my solute plus my solvent. That's my solvent here, okay. So my solute, I know I have 36 grams, so 100 minus 36 is 64. So then I know that I have 64 grams of water. So from all of this, from this mass percent, I can get all this information. So if they tell me I have 36 mass percent HCl, assume I have 100 grams of solution. So I have 100 grams of solution, right? That's on the bottom. And my solution is my solute plus my solvent. So if I have 100 grams of solution, that means I have 36 grams of HCl because it's 36% by mass. So 36 grams of HCl over 100 grams of solution. I can figure out what my solvent is going to be then. And then once I know the mass of my solute and my solvent, if I know mass, then I can figure out how many moles I have. And then I can do a lot more things. So this is a lot of times this is like the first step, taking this mass percent and kind of interpreting it. So let's see, what else do we have there? So mass percent is mass over total mass times 100. Parts per million is mass over total mass times a million, and parts per billion is mass over total mass times a billion. And so these are really small concentration units, and you'll see these if you look on your water bill. You can see they'll express certain contaminants you're allowed to have in your water. You want those to be, in parts per million, parts per billion. You don't want to have a lot of arsenic in your water, but they'll express those concentrations as parts per billion or parts per million, depending on what it is. So it's mass over total mass times a million, mass over total mass times a billion, and mass percent is just mass over total mass times 100. Let's do another one of these. We try to calculate mass percent here. Alright, so calculate the mass percent of sodium chloride in a solution containing 1.5 grams of sodium chloride in 50 grams of water. So I want the mass of my solute, that's right here, divided by my mass of my solution. Again, there's two parts to your solution. This is your solute, and this is your solvent. You know that this one's your solvent because you have more of it. And so if you want to find the mass percent of sodium chloride, the mass percent is going to be the mass of the sodium chloride divided by the total mass, which is 50 for the solute plus the 1.5 for the solvent. Sorry, 50 for the solvent and 1.5 for the solute. Add all those up times 100. Put that in your calculator. Make sure you add this up first. So you have 51.5. So you have 1.5 divided by 51.5. And what do you get for that? 2.91%. Is that right? Yep, 2.91%. So that's 2.91%. So we'll work that out in your calculator. Make sure you got the same thing. That's what we get for our mass percent there. So mass over total mass. Remember that the total mass is the mass of the solute plus the solvent. Here's another example down here. A commercial bleaching solution contains 3.62 mass percent sodium hypochlorite. what's the mass of the sodium hypochlorite in a bottle containing 2.5 kilograms of bleach solution? All right, so kilograms. We may have to convert these kilograms to grams. So this mass percent, remember what that mass percent means again. If I have 3.62 mass percent, that's like saying I have 3.62 grams of the sodium hypochlorite over 100 grams of solution. And now I want to know, okay, well, how many grams of sodium hypochlorite do I have in a 2.5 kilogram? Well, I don't know 2.5 kilograms. Can I convert that to grams first, and then I can just set up a proportion? So if I have 2.5 kilograms, and I know that, if you remember all our conversion factors, 1 kilogram means I have 1,000 grams, right? So that's 2, 5, right? 1, 2, 1, 2, oops, 1, 2, 3, 2,500 grams of solution. And now I can just take, I can just set it up over here. So if I have 3.62 grams of sodium hypochlorite and 100 grams of solution, how many will I have in 2,500 grams of solution? So I can just cross multiply, so I'm just going to multiply this over here, and so I'll end up with 2,500 times 3.62 divided by 100 grams of solution, and so when you work all that out, you end up with 90.5 grams of sodium hypochlorite.